Hey kids, welcome to section 6.2, solving exponential equations and inequalities. Today we're going to learn how to solve exponential equations and exponential inequalities. So in an exponential equation, variables occur as exponents. Exponential equation, x and the exponent. An exponential inequality also involves exponential functions. There are two properties. If you have an exponential function and b to the x equals b to the y, you can set the x and the y equal to each other. So for instance, if you have 3 to the x equals 3 to the fifth, then x equals 5. If the bases are the same, you set the exponents equal to each other. If you have inequalities, then if b to the x is greater than b to the y, then x is going to be greater than y. If b to the x is less than b to the y, then x is less than y. Again, the bases have to be the same. So for instance, if you have 2 to the x is greater than 2 to the sixth, then x is going to be 6. All right, let's see how we can use these to solve. So for instance, solve each equation. Letter A, 4 to the 2n minus 1 equals 64. Well, in order to use the rules for exponential equations, I need the bases to be the same. So I need to think of what number 4 and 64 can both be powers of, and the answer is 2. So I can replace 4 with 2 squared, and then I still have that exponent hanging out. And I can replace 64 as 2 to the sixth power. So now I can, since I have the bases are the same, I can set the exponents equal to each other. At the same time, I'm going to distribute this 2. So 2 times 2n is 4n. 2 times negative 1 is negative 2 equals 6. Then I can add 2 to both sides. So that's going to give me 4n equals 8. I can divide by 4, and my n equals 2. Remember, you can always check your answer by plugging your value back into the original equation. 2 times 2 is 4. 4 minus 1 is 3. 4 to the third power is 64. So it works. In letter B, I have bases of 5 and 125. I can write them both as powers of 5. So 5 to the 5x, I don't have to do anything to, but 125 is 5 to the third power, and I still have that x plus 2 hanging out. Now that the bases are the same, I can set the exponents equal to each other. So 5x equals, and at the same time, I'm going to distribute the 3. 3x plus 6. Now I want to get letters on one side, so minus 3x to both sides. That gives me 2x equals 6. Divide by 2, and you get x equals 3. Again, you can check your answer by substituting it back in. 5 times 3 is 15. 5 to the 15th, then do 3 plus 2 is 1. 125 to the fifth power, and they equal the same thing. If we take a look at letter C, the bases are 2 and 8. They both can be powers of 2. So this is 2 to the x equals, and 8 is 2 cubed, but I also have that 3 hanging out. Bases are the same, set the exponents equal to each other. X equals 3 times 3 is 9. Short and sweet. Letter D, the bases are 9 and 3, so I can set them as powers of 3. So 3 to the second, and I also have a 2x minus 1 hanging out, and 3 to the 6x. Bases are the same, so set the exponents equal to each other. At the same time, distribute. So 4x minus 2 equals 6x. Letters on one side, so minus 4x to both sides. Negative 2 equals 2x. Divide by 2. And you get x equals negative 1. So that's how you solve exponential equations. If we want to do exponential inequalities now, we do the same exact thing. We try to get the bases to be the same, and then we're going to set the exponents either greater than or less than, depending on the original problem. So bases here are 3 and 1 over 243. Well, I can set them as powers of 3. Don't really have to change the first one. But 243 is really 1 over 3 to the 5th power. So if I wanted to be 3 to a power, it'd be 3 to the negative 5. So 3 to the negative 5th power. Since the bases are the same, we can set the exponents equal to each other. So, or in this case, greater than or equal to. So 2x minus 1 is greater than or equal to negative 5. Add 1 to both sides. 2x is greater than or equal to negative 4. Divide by 2. We get x is greater than or equal to negative 2. If we look at letter B, my bases are 2 and 1 over 32. So I can leave the 2 alone. I can think of 32 as 2 to the 5th. And then I can make that 2 to the negative 5th. So this is 2 to the negative 5th. Then since the bases are the same, I can deal with the exponents. X plus 2 is greater than negative 5. Subtract 2, x is greater than negative 7. If I look at letter C, the bases are 4 and 64. I can do powers of 2. I could also do powers of 4 if I wanted to, but 2s are simpler. So I can replace 4 with 2 squared, and I still have the 2x plus 6 is less than. 64 is 2 to the 6th power, and I still have 2x minus 4. Now that the bases are the same, I can deal with the exponents. I'm going to distribute as well. So I'm going to get 4x plus 12 is less than 12x minus 24. Bring the letters to the left side by subtracting. This gives me negative 8x plus 12 is greater than negative 24. I can subtract 12 to both sides. This gives me negative 8x is less than negative 36. I can divide by negative 8, and when I divide by negative, the inequality switches direction. And so I get 36 over 8, but I can simplify that and get x is greater than 9 halves. If I'm looking at letter D, my bases are 25 and 1 over 125. I can do those as powers of 5. So 25 is 5 squared. I still have the y minus 3. Now 1 over 125 is 1 over 5 cubed, which is 5 to the negative 3. So I can do 5 to the negative 3 with y plus 2 still hanging out. So now that the bases are the same, I can deal with the exponents and distribute at the same time. So I'm going to have 2y minus 6 is less than or equal to negative 3y minus 6. Add 3y to both sides. That gives me 5y minus 6 is less than or equal to negative 6. Add 6 to both sides. That gives me 5y is less than or equal to 0. Divide by 5. Y is less than or equal to 0. All right, so now what if I'm given two ordered pairs and told to write an equation? So I have to write an exponential function for the graph that passes through the given points. An exponential function looks like f of x equals a times b to the x power. So if I'm given two ordered pairs, 0, 6.4, and 3, 100, I want to start with the ordered pair that has a 0 in the x. The reason why is because I'm going to substitute this x and this y into the original equation and see what happens. So I get y equals, which is 6.4, my bad. So 6.4 equals a times b to the 0. Now b to the 0 is just 1. So this tells me that my a is 6.4. All right, we're halfway there. Now we're going to take the second order pair, and we're going to use the a value that we just found. We're going to use the x, and we're going to use the y values again, and now we're going to figure out what b is. So I'm going to do 100 equals 6.4 times b to the third power. So now I need to solve for b, so I need to get rid of the 6.4 by dividing. And so 100 divided by 6.4 is 15.625 equals b cubed. To get to the b, I have to get rid of the cube. To get rid of the cube, I'm going to cube root both sides. So the cube root of 15.625 is 2.5. So now I have my a and b values, so I can write my equation. A equals 6.4 times 2.5 to the x. You can check and see if your equation is correct or not by plugging in 0 and seeing if you get 6.4, and then plug in 3 and see if you get 100. If you do, you did it right. If you don't, you did it wrong. Okay, if we look at letter B, again, we're going to start with the equation that has a 0 and the x. So we're going to say y, which is 256, equals a times b to the x, which is 0. B to the 0 is 1, so my a value is 256. Then I'm going to use my second order pair. My y is 81 equals my a, which is 256, times b, and my x value is 4. So to solve, I need to divide by 256. Now this gives me a really funky decimal, so I'm just going to leave it as 81 over 256 equals b to the 4th. To get rid of the 4th power, I need to take the 4th root of both sides. The 4th root of 81 is 3, and the 4th root of 256 is 4. So I get a b value of 3/4. So I can write my equation, y equals a, which is 256, times b, which is 3/4, to the x. So notice that in letter A, this is a growth function because of the 2.5, and letter B is a decay function because of the 3/4. Okay, now we can do some word problems. So a manufacturer distributed 3.2 million cans in 2010 made from recycled aluminum. In 2015, the manufacturer distributed 420,000 cans made from recycled aluminum. Assuming that the recycling rate continues, write an equation to model the distribution each year of cans that are made from recycled aluminum. So remember, we're using the equation y equals a times b to the x. Let's see if we can get some ordered pairs going. Well, in the beginning, 2010, we had 3.2 million cans. So in the beginning, year 0, we had 3.2 million cans, which is 3,200,000. 5 years later, so x equals 5, we now have 420,000 cans. There's my two order pairs that I can use now to write my equation. So my first order pair is what I'm going to use because it has an x of 0. So I've got 3,200,000 equals a times b to the 0. So my a value is 3.2 million. I can use my second equation now and say 420,000 equals 3.2 million, b to the x power, which in this case is 5. I can divide both sides by 3.2 million. And that's going to give me 0.13125 equals b to the 5th. To get rid of the 5th power, I can take the 5th root of both sides. The 5th root of 0.13125 is 0.67. So now I can write my equation y equals 3.2 million times 0.67 to the x. Seems like a pretty crazy equation, but it works. How many cans made from recycled aluminum cans were expected in the year 2055? Well, if we're starting in the year 2010, then the year 2055 is going to be 45 years later. So we can use the equation y equals 300 or 3.2 million times 0.67 to the 45th power. If I type this on my calculator, I get 0.05, which means no aluminum cans will be left. None. All right, here's another idea in word problems with exponential functions, something called compound interest. So, compound interest is interest paid on the principal of an investment and any previously earned interest. So, basically, when you're investing money, you can put money into an account that earns you simple interest, which means once a year they give you some extra money that you've earned in interest. They do that once a year. Compound interest is when they maybe give you interest once a week or once a month or once a quarter or once a day. And so interest is going to be computed a couple different times a year, depending on how often. So the formula is A equals P times 1 plus R over N to the NT power. Now, this A is how much money is in your account after a certain amount of time. The P is called the principal. That's how much money you put into the account. The R is your interest rate written as a decimal. The N is the number of times the account has been compounded per year. If it's weekly, it's 12. If it's or weekly is 52. If it's monthly, it's 12. Quarterly is 4. There's all sorts of different time numbers that the interest can be compounded. And then your T value is the time period in years. So we can use this formula to calculate. I'll write the formula at the top. A equals P times 1 plus R over N to the NT power. So find the account balance after 20 years. That's your T. If $100, that's your P, is placed into an account that pays 1.2%, that's your R. Interest compounded twice a month is going to be your N. So I have A equals, my principal is 100, 1 plus, my R value is 0.012. Remember, you got to change that to a decimal by moving it 2 spots left. Over, now N is the number of times it's compounded a year. So twice a month means that we are compounding 2 times 12 or 24 times. So my N value is going to be 24. And my exponent is N, which is 24, times T, which is 20. So I type this all into my calculator. I get $127.12. So if I put $100 into an account that is compounded twice a month, at the end of 20 years, I will have $127.12. Not a lot of money. Therefore, you want that interest rate to be as high as possible. Okay, if we do letter B, determine how much is in a retirement account after 30 years, that's your T. If $5,000, that's your P, was invested at 6.05%, that's your R. Compounded weekly, that's your N. So if we do the math, 100 or A equals the principal 5,000 times 1 plus my R value is 0.0605. My N is weekly, which means 52 times a year. My exponent is N, which is 52, times T, which is 30. If I plug this into my calculator, after 30 years, I will have $30,673. Even 673. That's a little bit better. All right, kids, that's how you deal with equations having to do with exponential growth and decay. If you guys have any questions, let me know. And as always, keep calm and keep trucking.